Good experiments and bad experiments. Let's start with a bad experiment. Bad experiment. You take your experimental units and these are just your people or your animals. Let's say you have a bunch of people. You give them a treatment. So maybe vitamin D pills. And you measure the response. See what happens. That's an experiment, but I don't know how well that will actually tell you that the vitamin D pills is what's really affecting this, or that things are being changed because of the vitamin D pills. How would you know? You have nothing to measure it against. How did you select the bunch of people? You just grabbed a bunch of people at the mall? So a bad experiment isn't actually pinpointed as to how you pick the people, the treatment plan, you don't have anything to compare it against, and what are you actually measuring. So let's talk about a good experiment. A good experiment is, instead of just taking a bunch of people, you randomly select your experimental units, your people. And split them up into two groups. We'll call this group A, and we'll call this group B. We'll give group A the vitamin D pill, and we'll give group B a placebo. They'll be my control group. And then we'll take those results and compare. That seems like it makes more sense, doesn't it? You would hope that someone would do that prior to prescribing a pill for you, making sure that it actually is effective. There's a couple things to know about this. It's helpful if participants don't know if they have the actual pill or the placebo pill. So it's helpful to have a single blind study, which means one person doesn't know what they're receiving. So maybe one group, they don't know if they have the placebo or the active pill. Another single blind study is if the researcher doesn't know. So it doesn't actually have to be the participant, it could actually be the researcher doesn't know if the person's getting a placebo or an active pill. When both don't know, that's the best study. It's called double blind. And I've heard this many times when I hear of a study. And it's the researcher and the participant. Don't know if it's an active pill or inactive pill, like the placebo. So what I imagine, and I think I was part of a group in college. I remember part of a psychology group, and they had you do different things. I remember them asking me questions in a room, and they took everybody and did everybody the exact same. And you didn't know which group you were in. So that is another big thing, is to make sure that you treat everybody the same. You would hope that if the doctor's prescribing these pills, okay, and they're the ones helping do the study, that they would bring someone in a room, give them a cup of water, and let's say a small pink pill, and then they take the next person into a room, give them a cup, and giving them a small pink pill. And they have no idea if the pink pill is active or not active. The person doesn't know if the pink pill is active or inactive. And the doctor has to treat everybody exactly the same to get an accurate study result. Now, to be able to pick people, remember how I said I want you to randomly select people. So when we did, a couple nights ago, we did this table D to randomly select people. To randomly select our subjects. And when I talked to another AP statistics teacher, they said to use a different method on the AP exam, because you have to list exactly how you would do this. And they said by using table D, their students always forget something. They forget explaining exactly how they would do it, and that's what the AP statistics exam usually asks for. So they said no matter whether there's 2,000 people, okay, you wouldn't normally do this, but you could say on an AP exam, and this is what you actually should say, is you're going to write every person's name on a different slip of paper. Place them in a hat. Shake the hat. And then pull the names of the participants for each group. And she actually said that even if you have 2,000 people in this study, that you're going to pretend that you would actually write every name of every person on a slip of paper, place them in a hat. You have to make sure that you shake the hat. That's where the random selection becomes. And then pull the names for each group. That will randomly select the groups. Now, personally, when we do an experiment, we're going to use table D and we're going to randomly select the subjects, because I don't have the time and I don't want you to take your time to actually write down every single person's name on a piece of paper. We're going to use Alden High School, which has over 1,000 students, I believe, or maybe, no, it's less than 1,000 students, but still, I don't want you to spend all day writing 500 names on slips of papers and then pulling them out and reading them to see who the people are that we've picked. But for the exam, the AP exam, that's the easiest way to receive the most credit. Now, there is another thing to take in mind, is that there is something called, and I'm going up to the top again, it's called the placebo effect. And what happens is when these people get taken into a room, given a cup with a pink pill, They don't know if they're getting an active pill or an inactive pill. And what ends up happening is this attention of being in a study and participating actually will cause people to have an increased response, even though they don't really have a pill that has any type of active ingredient in it. So people might get this pill, and let's say it's a vitamin D pill, and it might actually improve their health, even though the pink pill that they're receiving has no vitamin D within it. They actually might feel the effects of it, because the mind is such a great thing that you can actually psych yourself into being healthy. You can also psych yourself into being sick. So this placebo effect actually does occur, and so most people will have a positive reaction even if it's a placebo. But you have to see, does the vitamin D pill group have a more statistically significant reaction than the placebo group? Because both groups should actually have a good response. But the people that are getting the active ingredient, those people should really have the best response, and maybe, far surpass the response. Make sure that you select enough people. You can't do a study, and nor would you want someone to do a study where they only tested 5 people, and they put 5 people in the vitamin D group and 5 people in the placebo group. There's so many different factors that could go into those 5 people that you need to have a bigger group to be able to measure what the response is and accurately compare things. Okay, we'll move to another video.